Hello and welcome to A-Level Math. This is the second video in the series Binomial Theorem, and this video assumes that you have already seen the previous video on Binomial Theorem, which contains the basic idea and intuition of Binomial Theorem, the expansion of binomial expressions, and the general term of a binomial expansion. This video takes that video a step further, where we solve some more examples and take some harder problems. So make sure that you have already seen the video covering the basics of binomial theorem. If you haven't, please click on the I button above. Let's take up some harder problems now. A1, A2, A3 and A4 are the coefficients of four consecutive terms in the expansion of this 1 plus x whole to the power of n. So it says that A1, A2, A3 and A4 are four consecutive terms. They could be first, second, third and fourth term. They could be 7th, 8th, 9th and 10th term, or they could be any four terms, but the condition is that they are consecutive terms. So if we assume that we take these four consecutive terms, r plus 1th term, r plus 2th term, this is just my observation, or this is my choice. You could have taken any other terms like r plus 1, r plus 2 and r plus 3, or you could have taken like r plus 2, r plus 3, r4, r plus 4, r plus 5. I am just taking r plus 1, r plus 2, r plus 3th and r plus 4th term, but believe me, it will not matter. You can take any four terms, consecutive four terms of your choice, and the answer will still come. Okay, so we have taken these four consecutive terms. So what is this tr plus 1? What is the value of this tr plus 1? It is n cr 1 to the power of n minus r x to the power of r. Similarly, what is tr plus 2? Tr plus 2 can be written as t r plus 1 plus 1. So we can write it down as n c r plus 1, then 1 to the power of n minus r minus 1 and x to the power of r plus 1. Remember, head minus tail, and this is this is just the tail or the leg, whatever you may call it. T r plus 3 can be written as t r plus 2 plus 1. So this gives us n c r plus 2, 1 to the power of head minus leg, n minus r minus 2, and x to the power of leg, which is r plus 2. And similarly, tr plus 4 will be nc r plus 3, 1 to the power of n minus r minus 3, x to the power of r plus 3. So these four, ncr, ncr plus 1, ncr plus 2 and ncr plus 3, these are my coefficients, and these are actually a1, a2, a3 and a4, because the question says that a1, a2, a3, a4 are the coefficients, not the terms. So t's give us the term, and the question asks us to find out the coefficients. So these coefficients are actually these four, ncr, ncr plus 1, ncr plus 2 and ncr plus 3. These are the values of a1, a2, a3 and a4 respectively. So let's quickly write them down. We have a1 is equal to ncr, a2 is equal to ncr plus 1, a3 is equal to ncr plus 2 and a4 is equal to ncr plus 3. So these are what we have. Now we have to prove this result. So the general idea is that we start with LHS and then we reach out to RHS, but this may not work for this question because it has got a particular trick. The trick here is that instead of finding out the value of this thing, I will find out the value of the reciprocal of this thing. So instead of finding out a1 by a1 plus a2, I'll first try to find out a1 plus a2 by a1. That means the reciprocal of it. So let's see what I get. A1 by a1 plus a2 by a1. A1 gets cancelled out, so we have 1 plus a2 by a1. Now we put down the value of a2 and a1. a2 is ncr plus 1 and a1 is ncr. Now remember that in the binomial theorem we have learned a particular formula. The formula was ncr divided by ncr minus 1 is n minus r plus 1 divided by r. This is the formula that we already know. So the condition for this formula is that these heads should be equal and the tails should differ by 1. That means this tail should be 1 more than the lower tail. So the condition is that these ends should be same and that we should be having one more here than this thing. and then only you can apply this formula. And how to apply this formula? When you apply this formula, you forget about this thing. It is head minus tail plus 1, head minus tail plus 1 divided by tail. One more time I'll tell you, because it may be hard to remember. So the formula is something like this. The condition is that these two heads should be same. First of all, you have to see when you can apply this formula. That means you have to check the condition. The condition is that these two heads should be same, these two ends should be same, whatever it is, 5, 6, 7, they should be same on both the heads. And then this tail should be one more than this tail. Then you can apply the formula. And then what is the formula? While finding out the value, you forget about the denominator, you forget about this thing. So the answer will be head minus leg plus 1, head minus leg plus 1 divided by leg. So now let's see whether we can apply the formula here or not. So heads are equal here, and this tail is one more than this tail, so we can apply the formula. And the formula will be, let's keep this one as it is, and then we apply the formula, which is head minus leg plus 1 divided by leg. So this is the formula. Alright, now we can simplify it. So on simplification, we get 1 plus n minus r minus 1 plus 1 divided by r plus 1. Alright, so what do we get? We get minus 1 and plus 1 cancelling out. So we can take the LCM now. The LCM will be r plus 1 plus n minus r. R and r cancel out. So we have n plus 1 by r plus 1. So we have found out the value of a1 plus a2 by a1. So what is the value of its reciprocal? Its reciprocal is a1 plus a1 by a1 plus a2 is equal to r plus 1 by n plus 1. Okay, so we have found out the value of this thing, and now in a similar fashion we can find out the value of a3 by a3 plus a4. So let's see what we get. Let me clear some stuffs out here. Now let's try to find out the value of a3 plus a4 divided by a3, and then we will reciprocal it to find out the value of this expression over here. Okay, so we first divide a3 on both the terms. A3 by a3 plus a4 by a3 is equal to 1 plus a4 by a3 is equal to 1 plus, what is a4? It's ncr plus 3 by, what is a3? ncr plus 2. Now we can again apply the formula, because it follows the condition. The heads are equal, and that this tail is one more than this tail, so its value will be head minus leg r plus 3 plus 1, head minus leg plus 1 divided by leg. So its value turns out to be 1 plus n minus r minus 3 plus 1 divided by r plus 3, and then we take the LCM. So it's r plus 3 plus n minus r minus 3 plus 1. So r cancel out, 3 and 3 cancelling out, we get n plus 1 divided by r plus 3. So the reciprocal of this, which is a3 by a3 plus a4, let me write it down here, we get a3 by a3 plus a4. The reciprocal of this will be reciprocal of this, so it's r plus 3 divided by n plus 1. So now we have got the value of both of these terms, so we just need to add these two to get the LHS, and then we will similarly we will simplify the right hand side and see whether we are getting the same thing or not. So first let's add these two terms and find out the LHS. So what our LHS is, left hand side is then r plus 1 by n plus 1 plus r plus 3 by n plus 1, which is n plus 1 is the common denominator, so it's r plus 1 plus r plus 3, which is 2r plus 4 by n plus 1, 2 common, r plus 2 by n plus 1. This will not be 4, this will be 1, I'm sorry. Okay, now the right hand side. The right hand side is 2a2 by a2 plus a3. So we first try to find out the value of a2 plus a3 by a2. a2 plus a3 by a2. This will help us. So a2 by a2 plus a3 by a2 is equal to 1 plus a3 by a2. So what is the value of a3? a3 is ncr plus 2, and what is a2? ncr plus 1. We can again apply the formula, which is head minus leg plus 1 divided by leg, and on simplification we will be getting n plus 1 by r plus 2. You check it out. I think this will be the simplified value, and now we reciprocal it. So a2 by a2 plus a3 is equal to r plus 2 by n plus 1. So the right hand side is the twice of this. So 2a2 by a2 plus a3 is equal to 2 times r plus 2 by n plus 1, which is actually the same as the left hand side that we have got on simplification. And that is why this trick was useful. You might not have been able to do that directly. So this is actually the trick to find out the left hand side, and it's actually the simplest way if you follow this trick. Let's take another question. Find the value of r when it is been given that the coefficients of 2r plus 4th and r minus 2th terms in the expansion of this are equal. So we are given that the coefficients of these two terms are equal. So that means, first of all, let's try to find out the terms. So t 2r plus 4 is equal to t 2r plus 3 plus 1. So this will be our r now, which is ncr a to the power of head minus leg and x to the power of leg. So this is my 2r plus 4th term, and what is my r minus 2th term? R minus 2th term is t r minus 3 plus 1. So this is my new r now, which is 18c r minus 3 1 to the power of head minus leg and x to the power of leg. So these are my coefficients. Alright, these are my coefficients, and the question says that these coefficients are equal. All we need to do is just find out the value of r then. So we are given that 18c 2r plus 3 is equal to 18c r minus 3. So now we see that there could be two cases, either 2r plus 3 is equal to r minus 3. So let's see, what do we get? 2r plus 3 is equal to r. This is a particular combination problem. We have done a lot of these problems in combination. So if you haven't if you're not comfortable, please go and see the videos on combination. You'll get a better understanding of it. So we simplify to get the value of r. So r comes here, 2r minus r is equal to minus 3 minus 3. So r turns out to be minus 6, which is not possible because r cannot be negative. So all we have now is we can write this thing as 18c 18 minus r plus 3. Remember, ncr is ncn minus r. So we can write this as 18c 18 plus 3 can be written as 21. So it is 21 minus r, and now we can equate these two. 2r plus 3 is equal to 21 minus r. So 2r plus 3 is equal to 21 minus r. R comes here. So 2r plus r is equal to 21 minus 3. 3r is equal to 18 and r is equal to 6. So r is equal to 6 is our required value. Now let's take up another question. Write down the binomial expansion of 1 plus x whole to the power of n, where x is equal to 8. Deduce that this thing is divisible by 64. So let's take it step by step. They are asking us to find out the expansion of 1 plus x whole to the power of n plus 1. 1 plus x whole to the power of n plus 1. So instead of n, we are given n plus 1. No problem. Let's see what do we get. So it is nc0 x to the power of 0, then n c, I'm just saying n, but I'm actually putting n plus 1 because I have remembered the formula that way. For me, n is not a number. For me, n is that thing whichever is given on the power. So I try to remember it that way. You can have your own methods. So it's nc0 plus nc1 x to the power of 1 plus nc2 x square, and so on and so forth up till ncn x to the power of n. Okay, so this is the expansion. The first part is done. The binomial expansion is written now. Now they are asking is when x is equal to 8. So just put down in place of x is equal to 8, we get 1 plus 8 whole to the power of n plus 1 is equal to n plus 1 c0 plus n plus 1 c1 into 8. All I'm doing is just writing down 8 in place of x, then 8 square all the way up to n plus 1 c n plus 1 8 to the power of n plus 1. So now we have to prove the second part, that this thing is divisible by 64. So let's first of all try to find out the value of this thing. So if you observe that this can be written as 9 to the power of n plus 1 is equal to n plus 1 c0 can be written as 1, so I write it down as 1. N plus 1 c1 can be written as n plus 1 times 8, and then whatever is there I keep it as it is, so it's n plus 1 c2 8 square all the way up to, okay, let me write down some more terms so that it will be easier for you to understand in the next steps. N plus 1 c3 8 cube, n plus 1 c4 a to the power of 4 all the way up to n plus 1 c n plus 1 a to the power of n plus 1. Okay, so now what? Now you see we have got this term n 9 to the power of n plus 1, 9 to the power of n plus 1. We have also got 8n over here, we can multiply and we get 8n, and 8 plus 1 will give us 9, so we can actually find out the value of whatever is required. 1 plus 8n plus 8 and plus this thing we keep as it is, we don't mess with it, so it's n plus 1 c2 8 square plus n plus 1 c3 8 cube plus all the way up to n plus 1 c n plus 1 8 to the power of n plus 1. So this we don't touch now. Okay, so we take all these terms on the other side, so 8 plus 1 give us 9, so 9 to the power of n plus 1 minus 8n minus 9 is equal to this entire thing, n plus 1 c2 8 square plus n plus 1 c3 8 cube plus all the way up to n plus 1 c n plus 1 8 to the power of n plus 1. Okay, and now we have to prove that this thing is divisible by 64, which is very much obvious because if you take 8 square common, 8 square is there in all of these terms, so we can take 8 square common. Okay, let me erase the line above. So what I can do now, I can take 8 square common, so I will have n plus 1 c2 plus n plus 1 c3 into 8 plus n plus 1 c4 into 8 square all the way up to n plus 1 c n plus 1 8 to the power of n minus 1. So try to make yourself understand, because I've taken 8 square common, so from each and every one of these terms the power of 8 will get reduced by 2. So similarly at the end, n plus 1 minus 2 gives us n minus 1, and this 8 square is actually 64, so I get 64, and this entire thing is some integer, because remember that always the c values n plus 1 c2 n plus 1 c3, they always turn out to be integers, even natural numbers, they never turn out to be anything negative or fraction. So something integer plus integer into integer plus integer into integer, this has to be some integer. So this is some, I'm sorry for my handwriting, some integer. So that means that this entire thing is a multiple of 64. 64 into some integer means what? 64 into 1, 64 into 2, 64 into 3, 64 into 4, whatever it is a multiple of 64, and that is what they are asking us to prove, that this thing is divisible by 64. So we are done. Let's take up next question. We have to show in a similar manner that this thing is divisible by 225. We take more or less the same approach. Let me show you how to do it. First of all, write down the expression what is given. 2 power of 4n plus 4 minus 15n minus 16. So I can write this thing as 2 to the power of 4 whole to the power of n plus 1, because remember a to the power of m whole to the power of n is a power m into n. So if you multiply these two powers, you get this thing again. So I can write this thing down as like this. Okay, so minus 15n minus 16 remain as it is. 2 to the power of 4 is 16, power of n plus 1 minus 15n minus 16, and then I write this 16 as 1 plus 15. 1 plus 15 to the power of n plus 1 minus 15n minus 16. Okay, so now let me write down the expansion of this. 1 plus 15 whole to the power of n plus 1 is equal to n c0, then n c1 15 to the power of 1 plus n plus 1 c2 15 square, n plus 1 c3 15 cube, all the way up to n plus 1 c n plus 1 15 to the power of n plus 1. Now what is the value of n plus 1 c0? It's 1, plus what is the value of n plus 1 c1? It's n plus 1 into 15, and then whatever is there I don't mess with it, I keep it as it is. So I'm not writing it down, but you write it down yourself. Now what can I do? Again, in a similar manner, I'll multiply all of these and take it to the other side. So what I get, 1 plus 15 whole to the power of n plus 1 is equal to 1 plus 15n plus 15 plus whatever is there afterwards, this entire thing. I'm not writing it down, but you do write it down in your examination. I'm a lazy boy, you shouldn't be like me, please. So if I take everything on the other side now, what do I get? Okay, let me erase some stuffs. So 15 1 plus 15 to the power of n plus 1 minus 15 n minus 16 is equal to n plus 1 c2 15 square plus n plus 1 c2 c3 15 cube plus all the way up to n plus 1 c n plus 1 15 to the power of n plus 1. And remember that this thing is nothing but this thing, because we have simplified it and got this value. Okay, so this thing is actually this thing only. So we can write it down as 15 square common n plus 1 c2 plus n plus 1 c3 into 15 all the way up to n plus 1 in cn plus 1 15 to the power of n minus 1. This is exactly in the same way as in the previous question, nothing new in this. So 15 square is actually 225, and this is some integer. So we have now proved that this thing is actually a multiple of 225, and we are done. Okay, one more question. The second, third and fourth terms in the binomial expansion of x plus a whole to the power of n are 250, 720 and 1080. These are the second, third and fourth terms. Find the values of x, a and n. Alright, so we are given second, third and fourth terms. That means t2 is given to be 240. And what is t2? t2 is t 1 plus 1, which is n c1 x to the power of head minus leg a to the power of leg, and this is equal to 240. This is our first equation. Again we are given t3, which is t 2 plus 1, which is nc2 x to the power of head minus leg a to the power of leg, which is equal to 720. So this is our second equation. And we are given t4 is equal to t3 plus 1 is equal to nc3 x to the power of head minus leg a to the power of leg, which is equal to 1080. This is my third equation. Now I have three equations and three variables, so I can find out the value of x, a and n. So let me see how do we get it. So what is nc1? nc1 is nothing but n x to the power of n minus 1 into a is equal to 240. I've just simplified the first equation. nc2 is what? Okay, let it be nc1. It will help us to apply the formula. I'll tell you why. So instead of doing simplification now, let's straight away jump into finding the values. What I do is I divide the second equation with the first equation, and you will know why I'm doing it. So I divide these two equations. nc2 x to the power of n minus 2 a square divided by nc1 x to the power of n minus 1 into a is equal to 720 divided by 240. So I have done second equation divided by first equation. Okay, now a and a square give us a here. X to the power of n minus 1 x power n minus 2 will give us x over here. You can also do the subtraction of powers. So n minus 1 minus n plus 2 will give us power of 1. And what is nc2 by nc1? We can apply the formula. Remember, the heads are equal and the tail is 1 more than this tail. So it is head minus tail plus 1 by tail into a by x is equal to 720 by 240. So I get this thing. Alright. So what is n minus 2 plus 1? It is n minus 1 by 2 into a by x is equal to, what is 720 by 240? 0 0 cancels out. 24 3s are 72. So I get 3 over here. Okay, so I get a by x is equal to 3 into 2 by n minus 1, which is 6 by n minus 1. So I got the value of a by x. Now again I do equation number 3 divided by equation number 2. So if I do equation 3 by equation 2, I get nc3 x to the power of n minus 3 a cube divided by nc2 x to the power of n minus 2 a square is equal to 1080 by 720. And on simplification, I again get a over here and x in the denominator, and I again apply the formula for this part. So it is n minus 3 plus 1 head minus leg plus 1 divided by leg into a by x is equal to 1080 by 720. I can simplify 108 by 72. Okay, 9 1s are 9, 9 2s are 18, 9 8s are 72, 4 2s are 8, 4 3s are 12. So it is 3 by 2. So again a by x is equal to 3 by 2 into 3 divided by n minus 2. N minus 3 plus 1 is n minus 2, and then I put it in the denominator. So I can write this as 9 by 2 into n minus 2. So I get the value of a by x over here, and I get the value of a by x over here. I can equate it. Okay, so I can write down a by x is equal to 6 by n minus 1, 6 by n minus 1, and also a by x is equal to 9 by 2 into n minus 2. So both are a by x, so both of these should be equal, and from here we can get the value of n. So 6 by n minus 1 is equal to 9 by 2 into n minus 2. Okay, so 3 2s are 6, 3 3s are 9. What I get is 2 into 2 4. 4n minus 8 is equal to 3n minus 3. 4n minus 3n is equal to 8 minus 3. So I get n is equal to 5. So the value of n I get is 5. Okay, now again take equation number 1. What is equation number 1? nc1 x to the power of n minus 1 into a. So it is nc1 x to the power of n minus 1 into a is equal to 240. So this is the equation number 1. I now have the value of n, so I can put it over here. 5c1 x to the power of 5 minus 1 into a is equal to 240. What is 5c1? 5c1 is 5. X to the power of 4 into a is equal to 240. I can take 5 down here. So x to the power of 4 is equal to sorry, x to the power of 4 into a is equal to 240 by 5. 5 4s are 20, 40, 5 8s are 40. So I get x to the power of 4 times a is equal to 48. Now I have to find out the value of a and x, and I can use this thing now. So we have also this equation, a by x is equal to 6 by n minus 1. So we make use of it. So we have a by x is equal to 6 by n minus 1, which is 5 minus 1. So it's 6 by 4, which is equal to 3 by 2. So I have the value of a by x. So I can find out the value of a from here. So a is equal to 3 by 2 into x, and I can put this value of a over here and then find out the value of x. So x to the power of 4 into 3 by 2 into x is equal to 48. So x to the power of 5 is equal to 48 into 2 by 3. 3 16s are 48. 16 into 2 is 32. So x to the power of 5 is 32, which is 2 to the power of 5. So I get x is equal to 2. So I have got the value of x, I have got the value of n. All I need is the value of a, which is also easy. I just put on the value of x over here. So a is equal to 3 by 2 times 2, because the value of x is 2, is equal to 3. So the value of a is equal to 3. Value of a is equal to 3, value of x is equal to 2, and the value of n is equal to 5. That's it. Now one more question. If the coefficients of x to the power of r minus 1, x to the power of r, and x to the power of r plus 1 in the expansion of this thing are in AP. So this question involves AP as well. So if you haven't seen the videos on AP, do watch them before watching this video. It will help you a lot. So what are the coefficients of these terms? So the coefficient of x to the power of r minus 1 will be n c r minus 1, because we are having r minus 1 in the power of x. So the coefficient is n c r minus 1. Similarly, the coefficient of x to the power of r is NCR, and the coefficient of x to the power of r plus 1 is NCR plus 1. Now they are giving us that these three coefficients are in AP. So that means that 2 times of this will be equal to this plus this. That means this is what they are in AP means. So AP means that 2 times NCR is equal to NCR minus 1 plus NCR plus 1 R plus 1. Alright. So now if we are given this thing, then we have to prove that this thing holds. All we need is just a bit of simplification. So what I do is take this NCR down here in each of these terms. So I write 2 is equal to NCR minus 1 by NCR plus NCR plus 1 divided by NCR. I can straight away apply the formula in this case, because it satisfies the condition head and head are equal and this tail is greater than this tail by 1. But I cannot apply directly over here in this case, because head and head are equal, but this is in fact 1 less than this, so I need to reciprocal it. So what I do, I write this as 2 is equal to 1 divided by NCR by NCR minus 1, and I keep this thing as it is because it is already in the given format, NCR plus 1 by NCR. So 2 is equal to 1 by, the formula is head minus leg plus 1 by leg, plus here also the same formula, n minus head minus leg plus 1 by leg. So now I can again reciprocal it, which will give me r by n minus r plus 1 plus minus 1 plus 1 cancel out, n minus r by r plus 1. And all I need is just simplification of this thing, which will give me this. It should give me this, I think so. So I take the LCM, r plus 1 into n minus r plus 1, r square plus r plus n square minus nr plus n minus nr minus r square minus r. It's plus r square minus nr plus r square minus r. Okay. So minus nr give us minus 2nr. So I leave it to you for simplification. Actually it's just a bit of simplification and you should be getting this thing. So I leave it to you as an exercise, you can do it. And I take up another question, which is so in this case they are actually having 4 terms. As of now what we have discussed is that we are just given 2 terms, like a plus b or a plus x, whatever. We have been given 2 terms only, but here you are finding out 4 terms. So how to deal with it? So the problem is to split this into 2 terms. So what I do is, first I write down what is given. 1 plus x square plus x cube whole to the power of 11 is equal to, I factorize the inside part. 1 plus x plus, I can take x square common in these 2 terms, so x square common, 1 plus x, and then whole to the power of 11, and then 1 plus x common, and then I'll be having 1 plus x square, this to the power of 11. So I've factorized it, and now I can put this power of 11 in each of these terms. So it is 1 plus x whole to the power of 11 into 1 plus x square whole to the power of 11. So I have now got 2 binomial expressions and I can apply all my formula that I know. Okay, so now let's first read the question. Find the coefficient of x to the power of 4 in the expansion of this. That means we have to find out the coefficient of x to the power of 4 in the expansion of this. Okay, so let me make things a bit cleaner for you. We are given this expression, 1 plus x square plus x cube whole to the power of n, which we have written down as 1 plus x to the power of 11 into 1 plus x square to the power of 11, and we have to find out the coefficient of x to the power of 4. So we have to find out the coefficient of x to the power of 4 in here. So let's expand these two individually. What is the expansion of this thing? So the expansion of this is 11 c0 x to the power of 0 plus 11 c1 x to the power of 1 plus 11 c2 x square plus all the way up to 11 c11 x to the power of 11. This was easy, no problem. Now multiplied by, what is the expansion of this? 11 c0 x square to the power of 0 plus 11 c1 x square to the power of 1 plus 11 c2 x square to the power of 2 all the way up to 11 c11 x square to the power of 11. Now we have to find out the coefficient of x to the power of 4. Okay, so there are many ways we can get x to the power of 4. So this term doesn't contain any x, that means it's just a constant, and you see here we get x to the power of 4. What I mean to say is that this entire thing is to be multiplied with this entire thing. Understand this carefully. So that means this term will be multiplied to each of these terms, then plus this term will be multiplied to each of these terms, then plus this term is multiplied to each of these terms. In this way we'll have to expand the multiplication, and we then need to find out all those terms that have x to the power of 4. So what are the possibilities of getting x to the power of 4? The possibility is that this is a constant and this will be multiplied to this term, then we'll be getting x to the power of 4. Okay, then another possibility is that we are having x over here and it will be multiplied to somewhere x cube over here, but there is no x cube because this is constant, then x squared, then x to the power of 4, then x to the power of 6. In this fashion it will go. We will never be having an odd power in here, so we don't have to bother about this term. Okay, then x square when multiplied to this term will give x to the power of 4, and then somewhere we'll be having x to the power of 4 over here, which will be multiplied to this constant, which will give us x to the power of 4. So this is the technique that you will have to apply. Okay, so x to the power of 4, the terms containing x to the power of 4 will be 11c0 x to the power of 0 into 11c2 x square the whole square. This term contains x to the power of 4, then this doesn't contain. Then for this 11c2 x square, when this will be multiplied to this term over here, so 11c1 x square, then x cube we don't need to bother about the x cube over here, but x to the power of 4 over here will give us, when multiplied to this constant, will give us x to the power of 4, 11c0 x squared to the power of 0. So all these terms contain x to the power of 4, and these are the only terms that contain x to the power of 4. No other term contain x to the power of 4. So let's simplify these. So 11c0 is 1, and 11c2 is 11 into 10 divided by 2 factorial x to the power of 4, plus 11c2 is again the same thing, 11 into 10 by 2 factorial into 11c1 is 11 x to the power of 4, because x square into x square gives us x to the power of 4. 11c4 is 11 into 10 into 9 into 8 by 4 factorial, which is 24. 11c0 is 1 and into x to the power of 4. So these are the three terms rather, this, and these are the three terms that give us x to the power of 4. So you simplify these now. So I simplify them over here, small space I need. So I just write down these coefficients now. So it is 55, so it is 55 plus 11 into, this is again 55 into 11. 55 into 11 is 5 ones are 5. 55 into 11, let me check. 55 into 11 is 5 ones are 5, 10 0, 5 ones are 5, 605 it is. So it is 605 x to the power of 4, I don't write. Then what is this? 8 3s are 24, 3 3s are 9, so it is 330. So 330. So these are my coefficients, the sum of all these coefficients, which is 55 plus 605 is 660 plus 330, which is 990. This is my coefficient. This is my answer. Okay, one more question. If p be the sum of all odd terms and q be the sum of all even terms in the expression x plus a whole to the power of n, then we have to prove these things. So let's take the first question first. Okay, so what is x plus a whole to the power of n? X plus a whole to the power of n is nc0 x to the power of 0, sorry, x to the power of n, head minus leg it is. So it is n a to the power of 0 plus nc1 x to the power of n minus 1 a plus nc2 x to the power of n minus 2 a square, all the way up to ncn x to the power of 0 a to the power of n. Now the question says that p is the sum of all the odd terms. That means p is equal to the odd terms. P is equal to the first term plus the third term and so on. So p is equal to nc0 x to the power of n into a to the power of 0 plus nc2 x to the power of n minus 2a square plus nc4 a to the x to the power of n minus 4 x to the power of n minus 4 a to the power of 4, all the way up to the last odd term, whatever it is. And q is the sum of even terms. That means this, then the second term, the fourth term. So q is equal to nc1 x to the power of n minus 1 into a plus nc3, sorry, my 3 looks a little broken, x to the power of n minus 3 a to the power of 3 plus all the way up to the last even term, whatever it is. Okay, so this is x plus a whole to the power of n. So what is x plus a whole to the power of n? It is p plus q. Why it is p plus q? Because p contains all the odd terms and q contains all the even terms. So if you add p plus q, you'll be getting all the terms. So that is why x plus a whole to the power of n is p plus q. Now what is x plus a, sorry, x minus a whole to the power of n? What is the value of x minus a whole to the power of n? Remember that we know that it is nc0 x to the power of n a to the power of 0 minus nc1 x to the power of n minus 1a plus nc2 x to the power of n minus 2a square minus, and in this way it dwindles. That means start with a plus, then minus, then plus, then minus, and all the way. We have discussed this in the first video. So if you take all the odd terms together, so we'll be having nc0 x to the power of n into a plus nc2 x to the power of n minus 2 into a square. So all the odd terms will be having a plus beside them, and all the even terms will have a minus beside them. So we can take a minus common and then change the sign of all of them. So nc1 x to the power of n minus 1a plus nc3 x to the power of n minus 3 into a cube, all the way up to the last term. So x minus a whole to the power of n is actually p minus q, because this entire thing is p and this entire thing is q. Okay, so we have got x plus a whole to the power of n is equal to p plus q, and we have got x minus a whole to the power of n is equal to p minus q. These are the two things that we're gonna need. So let me erase everything else and write down what we have got separately for your convenience. X plus a whole to the power of n is p plus q, and x minus a whole to the power of n is p minus q. Now we have to prove this first thing. Prove that p square minus q square is equal to this thing. So let's find out what is p square minus q square. We can easily do it by p plus q into p minus q, because p plus q into p minus q is p square minus q square. So what it is x plus a power n into x minus a power n, x plus a power n, putting down the values of just p plus q and p minus q, nothing else, and x minus a to the power of n. So I can write this as x plus a into x minus a whole to the power of n, which can be written as x square minus a square whole to the power of n. That's what we have proved, because this is actually p square minus q square, which is p plus q into p minus q. Putting down the values, simplifying, we reach our desired result. And I won't be doing these two, I'll leave it to you as an exercise, but I'll surely give you some hints. You can use the fact that 4pq is actually p plus q the whole squared minus p minus q the whole squared. This is the formula that you might have come across in your class 10th. So use this formula, you'll be easily getting the answer. And for the third one, 2 times p square plus q square, use the formula that this is equal to p plus q the whole squared plus p minus q the whole square. I'm sorry. So use these two formula to find out the question number 2 and question number 3. And one last question, I guess, is it? Yes. So this is the last question. We have to find out the value of 0.99 up to the power of 15. Okay, up to 4 decimal places. I'm sorry. We have to find out the value of 0.99 power 15 up to 4 decimal places. So let's find it out. So 0.99 can be written as 1 minus 0.01 to the power of 15. So 0.99 can be written as 1 minus 0.01. Okay, now we have to apply the formula. Think of this as A and think of this as B. So it is 15C0, 1 is not required, 0 to the 0.01 to the power of sorry, I forgot the formula. What was the formula for 1 minus x to the power of n? It is nc0, 1 to the power of n minus 0, then x to the power of n, right? Yeah. Sorry, x to the power of 0. Yeah. So this will be power 0 over here. Then 15c1, 0.01, sorry, this is minus, to the power of 1. Then plus 15c2, 0.01 to the power of 2. Then minus 15c3, 0.01 to the power of 3. Then plus minus plus minus. So let's simplify these. 15c0 is 1 into 0.01 to the power of 0. So this entire thing is also 1. Minus 15c1 is 15 into 0.01. 15c2 is 15 into 14 divided by 2 factorial, 0.01 the whole squared, minus 15c3 is 15 into 14 into 13 by 3 factorial is 6 into 0.01 the whole cube. And then I omit the rest of the terms because they are extremely small, because 0.01 to the power of 4 is 0.00007 zeros and then 1, so that is extremely small. So we can omit all the terms thereafter because they will be extremely small. They will not add anything more, because we have to anyways find out up to 4 decimal places. So 1 into 1 is 1, minus 15 into 0.01 is 0.15, plus I can multiply this 105 multiplied by 0.01 square is 0.0001 minus 6 15 14 3 2s are 6 3 5s are 15 2 7 35 times 13 35 times 13 is 35 times 13 is equal to 5 3s are 15 5 plus 9 14 15 455, so it is 455 times 0.01 the whole cubed is 0. So 2 to 4 6, so 5 zeros and then 1, and then we multiply 1 minus 0.15 plus what is the value of this, 4 decimal places, so it is 0.0105 minus it is 6 shifted, so we'll be having 0.00455. So you simplify the value of this and that will be your answer. That's it. So we have discussed almost up till the highest level of questions for binomial theorem. I request you to go and practice harder with your with any of the standard books that you may follow, and we'll meet again in the next lectures. Thanks a lot. Study hard, stay smart, and keep studying with A-level math. Thanks a lot. Bye bye.